Question says solve for x in this equation. So we have 5 raised to the power x, okay, plus 5 raised to the power x plus 1 plus 5 raised to the power x plus 2 equals 775. So how do we do this? Solution. Okay, so for 5 raised to the power x plus 5 raised to the power x plus 1 plus 5 raised to the power x plus 2 equals 775. When we look at this side of the equation, okay, when we look at the exponents, we have x in common, okay, and we have equal base, so that means we can factor out this with 5 raised to the power x, okay. So try to factor out with 5 raised to the power x, so we have here as 1, okay, plus, so here we have 5, 5 raised to the power 1, which is written as 5, okay, plus, so here we have 5 raised to the power 2, okay. So when we say 5 raised to the power x, okay, times this, okay, we have to be 5 raised to the power x, 5 raised to the power x times this, okay. When we apply law of indices, so when we say 5 raised to the power x times 5 raised to the power 1, okay, so we have the same base, so we add the power, we have this, and when we multiply this with this, okay, so for 5 raised to the power x, okay, times 5 raised to the power 2, so we have it as 5 raised to the power x plus 2, which is this, okay. So let us equate everything we have here to 775. So we have 5 raised to the power x. So when we look at the parentheses, we can easily add up. So this is 1 plus 5 plus, for 5 raised to the power 5 is 25, okay, equals, okay, 775, okay. So we have 775, okay. Now let us work out the parentheses. So we have 5 raised to the power x, so for 1 plus 5 is 6, plus 5, we have it to be 31, equals 775, okay. So let us isolate this by dividing both sides of the equation by 31. So when we do this over 31, this is out, okay. So what do we have? We have 5 raised to the power x equals, so when we divide this by this, we have this as 25, okay. So we can easily get the value of x by putting this in index form. So when we write this in index form, we have it as 5 raised to the power 2, okay, which is 25. So we have the same base, we have it as 5 raised to the power x equals 5 raised to the power 2. So since we have the same base, we can equate the power, so we can say x equals 2, okay. So let us check the value of x to be 2, okay. Let us substitute back to this equation. Do we have 775? So let's check that, okay. So when x equals 2, okay, we have 5 raised to the power x, okay, plus 5 raised to the power x plus 1 plus 5 raised to the power x plus 2, okay. So what do we do? So let us replace the value of x with 2. So we have 5 raised to the power 2 plus 5 raised to the power 2 plus 1, okay, plus 5 raised to the power 2 plus 2. So for 5 raised to the power 2, okay, plus 5 raised to the power 3 plus 5 raised to the power 4. So for 5 raised to the power 2 means 5 times 5, okay, plus 5 raised to the power 3 means 5 in multiplying itself in 3 places. And for 5 raised to the power 4 means multiplying 5 by itself in 4 places, okay. So what do we do? So for 5 times 5, we have to be 25, okay. 5 times 5 is 25, 25 times 6 is 125, okay, plus, so 5 times 5 is 25, 125 times 5, so we have it as 625, okay. So when we add this together, 25 plus this, we have it as 775, okay. So now means the value of x equals to in this equation. The question says solve this equation. Okay, so we have to give a set of equations. So how do we do this? Solution. Okay, so for the first equation we have 4 raised to power x plus 1, okay, times 4 raised to power 2 into x minus 1 equals 0.25. Okay, so here we can, since we have the same base, so before that, let us write this as 4 raised to power x plus 1, okay, times 4. So when we when we distribute this, so we have 2 times x to be 2x minus 2 times 1 to be 2. Okay, so equals, so for 0.25 we can have this as 25 over 100. Okay, and we change it to a fraction, so we have this as 4 raised to power x plus 1, since we are multiplying the same base. So let's add up the power. We have 2x minus 2 equals 1 over 4. When we simplify this, so let's have everything in base 4. So we have 4 into x plus 1, okay, plus 2x minus 2 equals 4 raised to power minus 1. Okay, so for 4 raised to power minus 1, okay, so from here we can equate the power. So we have x plus 1 plus 2x minus 2 equals minus 1, and we collect the lighters by rearrange it properly. So we have x plus 2x, okay, so plus 1 minus 2, okay, plus 1. So let's equate everything to 0. So we have this as 3x when we add it up. So this is 2 minus 2 is 0, so we have this to be 0. Okay, so we divide both sides by 3, so that means the value of x equals 0. So for the second equation, so we have this as 9 raised to power 2x equals 1 over 3, okay, into 27 raised to power x. Okay, so when we look at this, we can have 9 as 3 raised to power 2, okay, times 2x, which is this, equals, so here we can have this as 1 over 3 for 27. We have it as 3 raised to power 3x. Okay, so here we have this as 3 for 2 times 2x is 4x equals, so here we have this as 3 raised to power 3x divide 3 raised to power 1. Okay, so we have this as 3 raised to power 4x equals, so we apply the division law of indices, we subtract the power, so we have 3 raised to power 3x minus 1. Okay, so here we have this as 4x equals 3x minus 1. So we collect the like times, 4x minus 3x equals minus 1. So here we have this as x equals minus 1.